Hey there, this is MathCamp321 presenting a video on even and odd functions. The term even and odd has to do with a function's symmetry. So today we're going to be talking about, first, even functions. If a function has symmetry over the y-axis, then it is called even. So what I've done for you is I've given you 4 examples of functions that are even or functions that have symmetry over the y-axis. Well, what does it mean to have symmetry over the y-axis? That means that if you were to fold or make a crease in your paper over the y-axis, one side of the graph would line up exactly with the other side of the graph. So in our first example, we see an absolute value function, which looks like the letter V of the alphabet. And this particular V has been shifted down 1 unit as indicated by this -1 outside of the function. That drags the whole thing down 1 unit. Now, if we were to fold over the y-axis, this right arm that serves as the V is going to end up matching up with this left arm perfectly. So we see that it has y-axis symmetry and that it is an even function. Now moving to the second example, we have here a quadratic function, y equals -x squared plus 2. This is the graph of a quadratic function, looks like a parabola. This particular parabola is turned upside down because of the negative in front, and it's also shifted 2 units up because of the +2 on the outside. And this particular parabola would be considered an even function because it too exhibits y-axis symmetry. If I were to fold along the y-axis, the one side of the parabola would line up exactly with the right side. Now coloring this in green is a little bit harder because this pen is a little bit temperamental, but this part that I'm making green, if I were to fold over the y-axis, it would line up with the blue side. So this is also an even function. Our third example is y equals cosine x. And some of you watching this video might not have even learned about trig functions before, but cosine is a trig function, and the graph of cosine looks like a wave, this oscillating wave. You also may have learned about it in a science class when you did sound waves or something like that. But it just so happens that cosine is also an even function. It does exhibit symmetry over the y-axis. So I'm going to take one side, the side to the right of the y-axis, and I'm going to color it in. And what I'd like you to do is imagine if I were to fold that green portion over the y-axis, would it look like the side that's on the left? And the answer is yes. Cosine x is an even function. It does have y-axis symmetry. And finally, we go to another function, y equals 1 over x squared. 1 over x squared is also an even function. It does exhibit symmetry over the y-axis. I'm going to shade the side on the right green. Now if I were to fold this graph over the y-axis, the green part would line up exactly with the blue part, which would make this an even function. So on this slide I've given you 4 examples of functions that are even, functions that exhibit y-axis symmetry. Later on in the lesson I'm going to show you how to determine if a function is even if you're not given the graph, you're just looking at the function itself. So I'm going to show you how to do that as well, and that's coming right up. On this slide, we're going to be talking about odd functions, and you might ask, well, what is an odd function? If a function has symmetry over the origin, then it is called odd. Symmetry over the origin can be thought of as a 180-degree rotation, which is like turning the graph upside down and it ends up still looking the same. So we start with the function y equals x, just a very basic identity function. Now it's going to be hard to illustrate this, so you have to have a little bit of an imagination. But I want you to imagine turning the graph completely upside down and asking yourself, would it look exactly the same as it would right side up? And again, tough for me to show you this on the computer here, but you have to have a little bit of an imagination. Maybe if you have this graph on a piece of paper, you could actually turn the paper upside down and see for yourself. But the first example here, this identity function, y equals x, this function does exhibit symmetry over the origin. If I were to turn the paper upside down, it would look the same as it would right side up. So this guy here is odd. Moving to the second example, we've got y equals x cubed. And in my school, we refer to this as a wiggle, because it kind of looks like it's wiggling a little bit. And again, if I turn the paper upside down, would this wiggle look exactly the same? We notice that there's one arm of the wiggle extends into quadrant 1, and the other arm extends into quadrant 3. And if I turned the paper upside down, would the arms still go into 1 and 3? And the answer is yes, this is also an odd function. The third example is y equals sine x. Well, this is another trig function, and many of you still have not learned about trig graphs yet. If I were to take this sine wave and turn the paper upside down, this first hump you'll see goes into quadrant 1. And if I turn the paper upside down, this hump over here, which looks like it's in quadrant 3, ends up being exactly in the position where this hump in quadrant 1 was. So this would look the same whether upside down or right side up. So the sine graph is also an odd function. And we finish with the graph of y equals 1 over x. It looks like these two boomerangs in opposing quadrants. One is in quadrant 1 and the other is in quadrant 3. And if I were to turn the paper upside down, the boomerangs would just flip-flop exact positions over the origin. So this is also odd. Now, after giving the 4 examples of odd, it may seem that the original graph always has to behave in quadrants 1 and 3. And that's not necessarily true. It could also happen in quadrants 2 and 4. So it's not always, along this diagonal like we see here in this line, or we see here with this wiggle, or we see with these opposing boomerangs. It could be in 2 and 4 as well. One more thing that I'd like to mention about odd, if you're confused about, well, when is a function odd or even, the word odd begins with O, and the word origin also begins with O. So maybe that could be a little thing to help you. Let's move on to slide 3.